Alright, gang, here we go. This is Chem 1, Unit 7, Part 2. We're talking about types of chemical reactions. Should be a lot of fun. Alright, so there's 5 main types of chemical reactions that I want you to know. Okay, these aren't too bad. You just kind of got to learn the patterns. Alright. Synthesis reactions are also known as combination reactions, and essentially they're just combining two things. All right, so simplest way is you just combine two elements to make some new compound. You could also combine two molecular compounds to make one big molecular compound. It doesn't really matter so much. All right. So really easy example of this is if you take hydrogen, right? We probably did this in class where we took hydrogen, blew it up with oxygen, and we formed a bunch of water. Okay, and let's just go ahead and balance this just for fun. So we got hydrogen. We know hydrogen's a gas at room temperature, and oxygen's a gas at room temperature. We know that by looking at the periodic table and what color it is. Okay, and then water is a liquid at room temperature, so we'll add that as a liquid. All right, now we got to balance this. We got two hydrogens, two oxygens, one oxygen, so we got to throw two up there, which changes our hydrogen. So there's your synthesis reaction of burning hydrogen. All right, pretty easy, making water. Decomposition reaction, the exact opposite of synthesis reaction. You're just taking one thing that's made up of multiple parts and breaking it up. And decomposition reactions are super fascinating, and they come in lots of different flavors. Okay, so just one simple example of this would be taking like aluminum oxide, so that'd be Al2O3. Okay, so that'd be aluminum oxide, and you're breaking that guy. When that burns, okay, when that decomposes, it would become aluminum, all right, which is a solid at room temperature, and then oxygen, which is a gas at room temperature. Okay, so notice that we started with this thing combined, and it broke up into these two guys like this. And aluminum oxide, well, we'll just say it's solid to start with. All right, let's go ahead and balance it. So we got two aluminum, so we'll throw two out there like that. All right, and then the oxygen, we got three here and two here. So we got three oxygens, two oxygens, so that means I got to change my aluminum real quick. That's what I get for not thinking it through. I should have picked a different example. So anyway, and then we'll throw there, four there. So we got four, six, cool. So there's your decomposition reaction. All right. Next type of reaction is a single replacement reaction. Okay, so if you look at this guy and just remember the front half of the alphabet, the letters from the front half, our notation, they are simply cations, positive elements, and then the latter half of the alphabet we are representing as anions. Okay, so anyway, so this would be some metal, okay, plus some metal with an anion, with a non-metal, okay, and then notice that the A and the B simply switch places, and so we got a single replacement. Only one of them is being replaced. That makes sense. Okay, now one trick to this is that your A element, okay, your A1, the one that starts out by itself, has to be more reactive than the B, or the one that's attached. And in order to tell if it's more reactive, you have to look at this thing called the activity series. All right, and so in this activity series, we get more reactive as we go up. Okay. So, for example, we've got magnesium and zinc and chlorine. So these are the two things that we have to compare the magnesium and zinc, because those are your two metals. So we got to compare those guys. So we've had magnesium and zinc. Magnesium's right here. Zinc's right here. Magnesium is above zinc, so that means our reaction can take place, and we end up with a complete reaction. We get this magnesium chloride, and then zinc gets plated off by itself. Okay. We also have aluminum and sodium chloride. Okay, so let's try this. So aluminum is right here, sodium's up here. Okay, so aluminum and sodium. Notice that the sodium is higher than the aluminum, so the aluminum cannot kick the sodium off, so you get no reaction. All right, single replacement reactions are super helpful. If you've ever heard of silver plating, okay, that's how this is done with a single replacement reaction. So if you have a grandma, congratulations, you're a human being. I'm pretty sure all humans have to have at least one. So anyway, if your family has an old set of silverware, okay, silverware used to literally be made out of silver, okay, and so, but after a while, silver tarnishes, it oxidizes, okay, and so in order to get it so it doesn't look tarnished anymore, you have to polish it. But essentially what you're doing when you're polishing silver is you're rubbing away the top layer of atoms of silver, and so eventually, after years and years and years of reacting this silver, or rubbing away the silver, you're left with just a scrawny piece of silver instead of that nice thick fork or knife that you used to have. So in order to get your silverware back to its former glory, you take it to a silver plater and they stick it into a vat with, let's say they probably use like, shoot dang, I don't know. I should look this up. They use something that'll be able to that would be able to kick the silver off. Okay, so probably, I don't know, probably nickel or something like that. And so anyway, and then it kicks the nickel off, and you end up with your silver getting plated back on, and then they polish it from there and make it all look nice and neat and stuff. Okay, second last type of chemical reaction we care about is a double replacement reaction. Okay, this looks exactly like the single replacement, only with one slight difference. Okay, now instead of one replacement, you have two replacements. You got your A is already attached to one nonmetal, and your B is attached to a different nonmetal, and essentially they're just flipping places. Your A gets attached to your Y, and your B gets attached to your X. Okay, this often is the reaction that forms precipitates. Okay, a lot of times they can form gas or water reactions. Okay. So a pretty decent example of this would be like if you react silver nitrate. Okay, so this is aqueous. Okay, and then we'll react that with, we'll say calcium chloride. Right, so calcium chloride. Oh, that should be a plus, not a yields. All right, so this would be a double replacement reaction. Okay, so the silver goes with the chlorine. Now silver, remember, always forms a +1 ion, so it'd be silver chloride. Now this, I happen to know, makes a solid. Okay, and we'll talk about that in a couple of videos, why that is. Okay, and so silver chloride, and then the calcium goes with the nitrate. Now calcium has a +2 charge, nitrate has a -1 charge, so that means we need 2 of these nitrates. Okay, so you end up with this guy here. All right, and we can balance this guy. So over here, we need 1 silver, 1 nitrate, 2 nitrates. So we'll throw that 2 in front of there, like that. So now we've got 2 silver, so we'll throw that 2 in front of that silver. Now we're at 1 calcium, 2 chlorines, and we're balanced. All right. Last one here is a combustion reaction. Combustion reactions are super fun. Okay, they always start with a hydrocarbon. Now this should make sense. Hydro means it's got some hydrogen. Okay, and then carbon means it's got some amount of carbon. So it's got some amount of hydrogen, some amount of carbon. All right. Hydrocarbons can also have oxygens. They can also have nitrogens, halogens. Okay, all sorts of things attached to them. But primarily in this class, we'll only worry about having hydrocarbons with hydrogen and carbon. And if we're feeling really frisky, we'll throw an oxygen in there. All right. But anytime you react or combust a hydrocarbon with oxygen, okay, you always form these two products, carbon dioxide and water. Always these same two things. Super nice. Highly exothermic. They burn. They make a bright flame. They're nice and warm. All right. So we start with hydrocarbon. Okay, so let's, I don't know, let's do something fun. We already balanced one of these. All right. So C5H12. All right, and we're going to react that with O2. This is a combustion reaction. We always make the same two things. That makes it nice. We'll make a CO2 and H2O. Okay. Pentane, pretty sure is a gas at room temperature. Could be a liquid, though. Anyway, and then oxygen is a gas. Carbon dioxide, obviously a gas. Liquid, water. All right, let's balance this. So we got 5 carbons, so we'll throw that 5 in there. 12 hydrogens, 2 hydrogens, so we'll throw 6 over there. And then 2 oxygens. Now let's think. So we've got 5 times 2, so that's 10 oxygens right here. And then 6, so 10 plus 6, so 16, so that means we need an 8 right there for oxygen. And that's the types of chemical reactions. You did them. Congratulations, we made it. Next part, we'll talk about how to predict products. That's really where all of this starts to get kind of come together. So do lots of practice problems, being able to identify the types of reaction. That's really an important skill to have. All right, so do your practice problems. Let me know if you have any questions, and I'll see you on the flip side.